This week we're going to look at trigonometric ratios of general angles. So that just means trigonometric ratios of all angles. Let's recall what our trigonometric functions were for our angles we learned in our trig lesson in Form 4. We learned that sine theta is the opposite over the hypotenuse, cosine theta is the adjacent over the hypotenuse, and tangent of theta is the opposite of adjacent, and all those sides are with reference to a right angle triangle. The sum of the angles in a right angle triangle is 180 degrees. So if one of those angles is 90, then the other two angles here and here, let's call it x and y, x plus y will be equal to 90, and that's the only way it would work. So therefore, using this method, we see that we are limited, x and y, the angles, are limited to their size because the sum of x and y will be 90. So therefore, x or y cannot be greater than 90. Here are the questions. Have you ever wondered, how do we determine the trigonometric function of angles greater than 90 degrees? Because I'm sure in assignments you have realized that you can put 110 degrees and find the cosine, sine, and tangent of 110 degrees in your calculator. However, which angle x or y would 110 degrees be? Because 110 degrees cannot be an angle in a right angle triangle. So how do we determine the trig ratio of any angle that is bigger than 90 degrees? And a second question you may have, where does a negative trig ratio come from? I'm sure there are times when you place trig ratios in your calculator, you see a negative answer come up. Where do those negative trig ratios come? Because if you look at our method of finding trig ratios, we always using the length of a side. There's no such thing as a negative length. So then why do we have negative trig ratios? So this class today, we will try to answer both questions and satisfy your curiosity. Now let's speak about quadrants. A circle or one full rotation can be divided into 4 quadrants. And we have our circle in red and we place Cartesian planes on it, and essentially what we have done is just that. We divided it into 4 quadrants, 4 equal parts. Each quadrant has a magnitude of 90 degrees or pi on 2 radians. So if we start at 0, which we can see right here, an anti-clockwise rotation will bring us to 90 degrees or pi on 2. So that is our first section or quadrant. Then another 90 degrees will bring us to 180 degrees or pi. And another quarter turn will bring us to 270 degrees or 3/2 of pi. And a full rotation brings us back to 0. So from 0 degrees to 90 degrees, we have our first quadrant. Then we have our second quadrant between 90 and 180 or pi on 2 and pi. We have our third quadrant in the third quarter, 180 degrees to 270 degrees or pi to 3 pi on 2 radians, and our last quadrant, quadrant 4, will fall over here. Let's look at our first quadrant in detail. So this here is our first quadrant, quadrant 1. Now if we draw a little triangle, our angle falling in the first quadrant, the general angle, we always label theta. And remember that this part of your x-axis has all the positive numbers. This part of your y-axis has all the positive numbers. And the length of this line here, the radius of the circle. Now, if you remember Pythagoras' theorem, the length of the radius by squaring each side, so the radius will always be positive. Okay. So let's determine our trig ratios for this triangle in blue. Sine is opposite over hypotenuse, so that'll be y over r. Y is positive, r is also positive. Cosine theta will be equal to adjacent, which is positive x, over r, and tan theta is opposite over adjacent, so that will be positive y over positive x. So what do we notice for the first quadrant? The first quadrant, all our ratios are positive. Now let's look at the second quadrant. So our angle, or I should say our general angle, will be right here. This is theta, because in the second quadrant our angles are obtuse, meaning that they lie between 90 degrees and 180 degrees. So let's look at our triangle being formed, and we will highlight this one here and we'll call it alpha. So for us to find the sine of all angles that are in our blue triangle here, what do we see happening? This side of our axis, x is negative, so this will be negative x, but the y is still positive, so we have positive y. The sine of our general angle will be sine is opposite, so that will be positive y over our radius, which is always positive r. The cosine will be, cosine is adjacent, negative x over positive r. And this we see that our cosine will give us a negative answer. Tangent is opposite, which is positive y over negative x. And again, a positive divided by a negative gives us a negative answer. So what do we see in the second quadrant? In the second quadrant, only the sine is positive. In the third quadrant, our general angle, again, we're starting from here, it goes all the way around to reach here. Okay? And so we use our angle here for our reference angle in the triangle we're going to find our ratios for. So let's see what happens in this quadrant. Again, let us determine what sign our x and y would get, because r is always positive. So on this side, x is negative and y is also negative. If you remember your Cartesian plane, your negative numbers would have come down here, and your negative numbers come on this side, if this is the origin. So let us work out our ratios like we were doing before for this triangle here. The sine of our general angle that falls in the third quadrant will be sine is opposite, which is negative y over hypotenuse, which is positive r. So this would give us a negative sign. Let's look at cosine theta. Cosine is adjacent over hypotenuse, so that gives us negative x divided by positive r, and this is also negative. And finally, the tangent of theta is opposite over adjacent, so negative y over negative x, and this is positive. So in the third quadrant, only tangent is positive. Now let's look at the fourth quadrant. In the fourth quadrant, our angle starts at 0 and goes all the way around. So this would be our angle in the fourth quadrant. So we'll call this theta. So let's look at what happens with our x and y. The x value is positive and the y value, however, is negative. So we start with sine theta, and remember our radius is positive r, so sine theta will be our negative y divided by positive r. So this makes sine negative. Our cosine of theta will be equal to positive x over positive r. So this makes cosine positive. And last, we have the tangent of theta which will be negative y over positive x. Negative divided by a positive is negative. So this means for the last quadrant, only the cosine is positive. The sine and tan of the angle that falls in the fourth quadrant is negative. So to sum it up, we can say that the sign of trigonometric ratios is an indicator as to which quadrant the angle lies. So in other words, depending on the size of the angle, we would know whether its trig ratio would be negative or positive. So the sign, positive or negative, of a trig ratio only indicates in which quadrant the ratio belongs. And as you can see in our diagram, in the first quadrant, all the ratios are positive. In the second quadrant, only the sign is positive. In the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. Now let's check our understanding of the lesson so far. We have a question here: determine the quadrants in which each of the following angles lies. So our first angle is 120 degrees. 120 degrees would fall between 90 and 180, so therefore this one lies in the second quadrant. Now let's work with radians. We have 3/4 pi. Now here is pi radians, or in other words 1 whole, 1 pi. But we have 3/4. 3/4 of pi is more than 1/2 and less than a whole. So this also falls in the second quadrant. Now, if you don't understand fractions, I think you should probably refresh your memory on the size, the general size of fractions. Now we have 7 pi on 4. 7 pi on 4 is more than 1 pi. Because 7 on 4 is 1 and 3/4. So where would it fall? Well, 7 on 4 pi would actually be in the fourth quadrant, because 7 on 4 is greater than 1/2, because it's 1 whole and 3/4. So this would lie in the fourth quadrant. And negative 56, a negative angle, is as a result of a clockwise rotation instead of a anti-clockwise rotation. So positive angles will be anti-clockwise rotations and negative angles will be clockwise rotation. So this means that this angle started from 0 and went this way, 56 degrees. So this would be in your fourth quadrant as well. Let's do this other example to check our understanding. It says, given that the tangent of theta is negative 5/8 and theta is obtuse, find, without using a calculator, sine theta and cosine theta. So the information we have been given is that the tangent of theta is negative 5/8. Now remember, this negative sign only gives us an indication as to which quadrant we are looking at. They also told us that theta is obtuse. Obtuse angles lie between 90 and 180, so that means that theta lies in the second quadrant. Because the second quadrant goes from 90 degrees to 180 degrees, or we could say from pi on 2 to pi in radians. So in quadrant 2, if we recall, quadrant 2, only the sine of theta is positive. So what does that mean for the others? That cosine theta is negative, and that tangent of theta is also negative, which we already see because they told us that it was negative 5/8. But for us to find sine and cosine, we need our hypotenuse. So let's sketch a little triangle here. If this is theta and tangent of theta is 5/8. Notice we dropped the sign because, like I said, the only purpose of the sign is to help us determine which quadrant it falls in. So tan is opposite over adjacent, so that means that here is 5 and here is 8, making the hypotenuse here be the square root of 5 squared plus 8 squared, which is equal to the square root of 89. So now that we know the hypotenuse, we can find all our ratios. So already tangent of theta was negative 5/8. So sine of theta, sine is opposite, which is 5 over hypotenuse, which is the square root of 89. And sine is positive, so this stays as is. And the cosine of theta will be adjacent, which is 8 over hypotenuse root 89. But remember that the cosine is negative, so therefore we have to put a negative sign here. This is our solution. So now we're going to speak about reference angle, and the reference angle, which has a symbol alpha, is the acute angle that the general angle theta is associated. So if we remember our definitions of our trig ratios using the right angle triangle, the x and y angles were always acute angles. And when we did the signs, explanations to the signs of the trig ratio, there was always an acute angle within the right angle triangle drawn in each quadrant. And that acute angle inside that right angle triangle is what we call the reference angle. So now we're going to learn how do we calculate the reference angle and why is the reference angle that important. So in the first quadrant, the general angle theta, the angle we were examining, is the same as the reference angle because in the first quadrant all angles are acute. So alpha is equal to theta in the first quadrant. In the second quadrant, however, where our obtuse angles lie, our reference angle will be right here and our general angle is the actual angle we are examining. So therefore, our alpha or the reference angle is related by subtracting our general angle from 180 because this straight line is 180 degrees. In radians, this would be pi minus theta. In the third quadrant, our reference angle is formed again with our x-axis here because remember this is where we drew our triangle, if you remember clearly. So this here is our reference angle, alpha, and your general angle starts from here, represented by the black curve, and it goes all around to reach the line. So how do these two relate in our third quadrant? In our third quadrant, alpha is actually equal to our general angle minus 180 degrees because the general angle is greater than 180 degrees by our reference angle alpha, and in radians this would be the general angle minus pi. And our last quadrant, because in our last quadrant, in third and fourth quadrants we have reflex angles, so in the fourth quadrant our reference angle will be that little part which completes the whole revolution. Do we see that? So the reference angle is right here, and our angle highlighted in black, our rotation in black, is our general angle. So what's the relationship between the two? The relationship is that our reference angle will be 360 minus the general angle. And in radians, this will be 2 pi minus theta. So this is how we find our reference angle, or the acute angle that relates to our general angle. So when we learned about our sine theta, cosine theta, tan theta in Form 3 or Form 4, and we learned how to find them using our right angle triangle that was only limited to acute angles, the reason why this is still true and why this is still useful is because, as we can now see, all general angles, depending on which quadrant they fall in, so all general angles have an acute angle that they are directly related to, and that acute angle is called our reference angle. So this is a table summarizing all our formulas. In quadrant 1, again, alpha equals theta. Quadrant 2, alpha is 180 minus theta, or pi minus theta. In quadrant 3, alpha is theta minus 180 degrees, or theta minus pi. In the last quadrant, alpha is 360 degrees minus theta, or 2 pi minus theta. Express each of the following trigonometric ratios as the same ratio of an acute angle. Now, once you see they say an acute angle, we know they're talking about our reference angle. So let's look at the first one. Sine 2 pi on 3. So this is the same as 2/3 pi. Recall that pi is half a rotation, or in degrees it is 180 degrees. 2/3 is greater than a half, but less than 1. So therefore 2/3 pi would fall in the second quadrant. In the second quadrant, to find our reference angle, in radians it is pi minus our general angle. So therefore alpha is equal to pi minus 2 pi on 3, which gives us simply pi on 3. Now, in the second quadrant, sine is the only positive ratio. So therefore, our answers, and I'll put them here. Number 1, sine 2 pi on 3 will be the same as the sine of pi on 3, because the sign is positive in the second quadrant. Let's look at the second question. We're looking at cosine 210 degrees. 210 degrees falls in the third quadrant because it is in between 180 and 270. In the third quadrant, is cosine positive or negative? Cosine is negative, so cosine is negative. Alpha will be equal to, in the third quadrant, it is, alpha is theta minus 180 degrees. So that will be 210 minus 180 degrees, which gives us 30 degrees. So therefore, the cosine of 210 is, since cosine is negative, it will be negative cosine of 30 degrees. And the last one, we have tan of 11 on 6 pi. Now, on the side here, 11 on 6 is the same as 1 whole and 5/6. So that is greater than, this would be greater than 1.5 pi. So therefore this is in the fourth quadrant. In the fourth quadrant, the only positive is cosine, so tangent is negative. So how do we find our reference angle? In the fourth quadrant, our reference angle is 2 pi minus theta, and theta in this case is 11 on 6 pi. So this is actually 12 on 6 pi minus 11 on 6 pi, which gives us pi on 6. So the tangent of 11 on 6 pi is equal to the negative tangent of pi on 6. And this is how we relate our general angles ratio to the ratio of an acute angle. So here we're seeing a general summary of everything we've learned so far. So first of all, we've learned how the quadrants come to be. We have 4 quadrants in one full rotation, and we're starting from the x-axis, going right back to the x-axis. First quadrant, all trig ratios are positive. So if the angle stops, I should say, at the first quadrant, all its ratios, sine, cosine, and tangent will be positive. If the rotation stops in the second quadrant, where the angle lies between 90 and 180, then only the sine is positive. If it is in the third quadrant, only the tangent is positive, and in the fourth quadrant, that only the cosine is positive. And the table on the right tells us how do we determine the acute angle that all our angles will be related to. So if an angle falls in quadrant 2, we know how to find the acute angle it is related to. If an angle falls in quadrant 3, we know how to find the acute angle that it is related to, and the same for quadrant 4, using these formulas that we have in the table. Also, we learned how to relate the ratio of the general angle with the ratio of its reference angle, using the facts that we know which ratios are positive and which ratios are negative in the different quadrants. Now take the time to practice some of your own work in your textbook, which I have placed the page numbers and the exercises which you can do in your assignment, but that is just practice. But this week you will have a quiz that is due at the end of the week on what we have learned today.